In this example problem, we're going to be doing a bit of chi-square distribution, and this is a statistical tool that you can use when you're checking the effects of one variable on another variable. In this first problem, we're just going to do the math of how to find your test statistic for doing a chi-square distribution. And for this, we have a health study going. And researchers are investigating the effects that nudges have on the choice of beverages and the dining hall at a college campus. So for a nudge, which we're going to deem to be our experimental weeks, they do a little bit of an advertising campaign to rethink your drink, to drink something healthier, namely in this case, water. So during these nudge weeks or these experimental weeks, they put up a bunch of advertising. This is you should drink water instead of soda or iced coffee or whatever students are drinking nowadays. And because this is still a test, in this case, of study, we need it properly designed. There are control weeks to make sure that, it isn't just the student's choice doing this, it's actually the effect that the nudges are having on the beverage choice, the relationship between two variables. So in our control weeks, we're not going to advertise. Requirement one, we're given some information over here that they have calculated about what students' beverage choice was during the control weeks and what students' beverage choice was during the experimental weeks. In order to figure out what our chi-square statistic is, the first thing we need to do is figure out our totals. We're going to figure out the total for each row, each column, and then down here in the bottom right corner, we're going to also figure out the grand total. So I can use Excel's sum function to do so. This is going to be equal to the sum of 413 and 468, and in total, students purchased 881 waters over the whole entire time period, both control weeks and experimental weeks. Same thing over here for other beverages. It was 237 during control weeks and 184 during experimental weeks. Put those two together and you get 421. Down here for control weeks, we can find the sum of these two numbers, and that is 650. For experimental weeks, the total amount of beverages consumed by our college populace is 468 plus 184 is 652. And for the bottom right-hand corner, I could find either the sum of the columns or the sum of the rows. They're both going to lead to the same number. All in all, across this time period, that is 1,302 beverages that were consumed. So we are asked in this case to start off by figuring out what percentage of these students drank water. Well, we have the total amount of waters that were consumed, 881, and we have the grand total, the total amount of beverages that were consumed, 1,302. So if I take the amount of waters, the row total, and divide it by the grand total over here, I get our percentage. So this equals 881 divided by 1302, formatted as a percentage, 67.7%. So 67.7% of all beverages consumed, or all students that drink beverages here, drank water over this time frame. For chi-square distribution, you're going to compare your actual observed results against your expectations based upon the percentage of students that met certain criteria. The percentage of beverages consumed during control weeks versus experimental weeks, the amount of beverages consumed were water versus other beverages. So I need to figure out what my expected amounts are. We'll do it the simple way right now. 67.7% of beverages consumed are expected to be water. Well, how many beverages were consumed during control weeks? That is 650. And based upon that ratio, that 67.7% of students drink water, 67.7% of those 650 beverages should have been water. So I can take the total amount for the criteria we're looking for, multiply it by my known percentage, and I get 439.82. Let's do the same concept for experimental weeks. There are 652 total beverages consumed during experimental weeks. If 67.7% of those were water, we would expect 441.18 bottles of water to be consumed during experimental weeks. Let's do the same concept down here for our non-water drinkers. If 67.7% of students drank water, the complement of that should be the amount of students that drank other beverages. I'll just do it off to the side so we have the number right here. 100% minus that 67.7% is 32 point bunch of craziness over here. We'll say 33%. Let's get rid of the decimals down here to make things work out. There we go. So let me zoom in a little bit for you guys as well. Perfect. So we're expecting that if this percent was water, this percent is going to be students that drink soda or iced coffee or whatever. Well, I can do the same concept that I did before. Take the percent of that percentage, that complementary percentage, and multiply it by the total amount of beverages consumed during those respective weeks. So for this, I could say this was 650 times that 32.33% is 210.18 expected non-water drinkers during control weeks. If I want to do it another way without having to figure out my number separately, I could just say for experimental weeks, it would be 652 times 100% minus the percentage that we know of water that was drank, 67.7%. Either methodology will get you there. And we got 210.82 expected non-water drinkers during experimental weeks. So for requirement 5, we're going to find our chi-squared statistic, our x squared, if you will. And the way that you find this is you break down all of the different components. And by components, I mean intersections in the data that you have. So we have the intersection of water in control weeks. We have the intersection of other beverage in control weeks. We have the intersection of water in experimental weeks. And we have the intersection of other beverages in experimental weeks. So we have 4 possible combinations that we could have based upon the 2 variables that we have in our data. How you find this is you take the sum of each component's difference from expectation and then add them together. So I'm going to do this very long form to show how we do it over here. For our water drinkers during control weeks component, one of our 4 possible combinations, I'm just going to use that formula that's listed here up above. The observed amount minus the expected amount squared divided by the expected amount. So for this could be equal to the observed amount of water that was consumed during control weeks. Let me go up and find that number. The observed amount of water that was consumed during control weeks is here in cell C6, 413. I'm going to subtract from that the expected amount of water that we would have during control weeks, and our expected water drinkers during control weeks was 439.82 in cell D16. Close that parenthesis, and then I'm going to square it. So to the power of 2. And then I'm going to divide it by that expected amount for that particular condition, that intersection. And that expected amount of water during control weeks is once again that 439.82 up here in cell D16. And I come up with 1.64. So this implies in this case that our observed amount of water that we had, the squared value of that observed amount of water that was consumed during control weeks, was 1.64 waters above, or 1.64 times above expectation. And I'm just going to repeat the same process all the way down the line. So for water drinkers during experimental weeks, equals parenthesis, go up and find that intersection. Water during experimental weeks is 468. And subtract from it the expected amount. And our expected water during experimental weeks, we found in requirement 3 is 441.18. Close that parenthesis, square it, and divide by that expected amount of 441.18. We come up with 1.63. So we got 2 components down. Let's go on to the other 2. Non-water drinkers during control weeks equals, open a parenthesis. The amount of non-water beverages or other beverages consumed during control weeks was 237 minus, and then I go and I find my expected non-water drinkers during control weeks, which we found in requirement 4 of 210.18. Close the parenthesis, square it, and then divide by that expected amount of 210.18. And I come up with 3.42. And for the last component we have over here, we take the observed amount of non-water drinkers that we had during experimental weeks. During experimental weeks, the amount of other beverages consumed was 184. Subtract from that our expected amount that meets that condition, which we have right here, requirement 4 is 210.82. We square that, and then we divide by the expected amount of 210.82. And we come up with 3.41. So to find my chi-squared statistic, all I need to do is find the sum of the 4 components. And it comes out to 10.10. And just like all of the other statistics we found so far, the T statistic, the Z statistic, etc., this is a measure of differentiation from another number. In T and Z, it's from mean. In this case, it's from expectation. So in future problems, we're going to now use that to do what we've been doing for all hypothesis tests, convert it to a probability.